Alright guys, you're welcome to this video. In this video we are going to be looking at equipment reliability, which is a very functional and fundamental aspect of science laboratory technology. So what is equipment reliability? Equipment reliability is the probability that an equipment, system, component or device will perform its intended functions without failure under stated conditions for a specific or specified period of time. So when an equipment can be able to perform its functions, all right, it can actually perform its functions without having any form of failure, okay, and under the stated conditions for that specified period of time. It can be 10 minutes, it can be 20 minutes, but it is able to perform its functions, then it means that that equipment is reliable. All right, so when we are calculating reliability, we are doing that so we can be able to know how long a particular equipment can actually stay without failure and of course perform its functions. So there is a very major parameter that we consider when we are studying equipment reliability. That parameter is known as Mtbf. Now Mtbf is called mean time. It's called mean time between failures, or sometimes mean time before failure. All right, so it's important to note that this mean time between failure helps us to know how long, okay, a particular equipment can actually work and how long it can actually stay before it fails completely. All right, so now the mean time between failures, which is Mtbf, all right, has a formula. All right, it has different formulas though, all right, but some of the standard formulas are what I'll be giving to you. Now please, I want you to know that these formulas are dependent on the parameters you are given in the question. So basically your Mtbf is equal to, generally your Mtbf is equals to total test time, your total test time divided by number of failures. The total time that you are actually testing the equipment divided by the number of times that equipment has failed, number of failures. All right, and Mtbf is a time, it's time, okay, so this is expressed in the time that you give it. If you're operating that equipment for just few seconds, then it means that you express it in seconds. If you're operating it in minutes, you express it in minutes. If you're operating in hours, you're operating in days. If it's months, it is. If it's years, you express it. So there's nothing like you have to convert to seconds. There is no standard unit. It's dependent on the time that you're operating that equipment. All right, so it is total test time, and total test time is given as T all over number of failures is N. So your Mtbf, we can say abbreviating it now, we have T all over N. All right, but most times, okay, I also want to let you know that Mtbf can also be expressed as 1 all over lambda. Now you might be wondering, what is lambda, what is 1? Now lambda is known as failure rate. Lambda is known as failure rate, okay, so they can give you the rate of failure. All right, just divide 1 by the rate of failure to know the mean time between failures, depending on the parameters that you're giving. Now I also want to let you know that Mtbf, if they give you the values, for instance, you're giving the time, the final time and the initial time now for the failure. All right, so Mtbf is also the final time. We express it as Tn minus T naught divided by N. All right, this is also another formula for Mtbf. Okay, so I want to let you know that Mtbf will help you to determine the reliability of that equipment, and reliability has its own formula. Reliability is given as e raised to the power of minus lambda t. All right, e raised to the power of minus lambda t. Remember, I told you that lambda is failure rate. Now t is what we call maximum time. All right, more like the time that the equipment is expected to operate. For instance, now you are testing the equipment for a total of 1000 hours. That is the maximum time. Maybe the equipment might go bad completely at 900 hours, at the 900th hour. Okay, and of course you have to decide, okay, that the maximum operating time, okay, the maximum operating time is 1000 hours. That maximum operating time is T. All right, this E, of course, we know is exponent. Your R is reliability. Then there's what we call unreliability. Unreliability is given as Q. Unreliability is 1 minus reliability. That is 1 minus R, which is 1 minus e raised to the power of minus lambda t. All right, 1 minus e raised to the power of minus lambda t. So it's very important to take note of that. All right. Okay. So take for instance, now you are giving Mtbf in a question, and you're told to look for lambda. You're told to look for the failure rate. They just give you Mtbf or in a question, and you're told to look for the failure rate. Now, if you look at the formula now, Mtbf is equals to 1 all over lambda. It means that lambda is also equals to 1 all over Mtbf. All right, 1 all over Mtbf. So in as much as your Mtbf is the inverse of your failure rate is also the inverse of your mean time between failures. All right, so we'll be looking at a question quickly that would help us to understand the concept of reliability, equipment reliability. We'll be testing the reliability of an equipment at different trials, all right, different periods of time when the equipment failed. We want to know how reliable that equipment is. All right guys, so we have a question here. It says certain components are put on accelerated life test and their failures occurs at a certain time from the start of the test in 100 hours. So this 100 hours is the maximum time. All right, so now it means that it was actually placed on a test, to know what will happen at the 1000th hour. All right, to know what will happen at the 1000th hour, to know the percentage of the ones that will still be reliable, that will still be working, and the ones that would have failed completely, that is no hope for them to be reliable again. Okay, so now we're given a set of values here, and all of these values are expressed in hours. All right, so these were their different periods of failures. At the 18th hour, that the 40th hour, 98th hour, 110, 186, down to the highest 959th hour. All right, so we are told to calculate the following: the mean time between failures, the reliability, then B, determine the unreliability, which is Q, and C, we are told to interpret the result. Now, it's very important for us to, first of all, note that when it comes to Mtbf, we have to determine the summation of all the values, except you are giving just the highest value and the lowest value. But when you're giving a lot of values like this, now to calculate the Mtbf, you take the sum and you divide by the number of values. So now let us solve that. So solution to this. Now let's calculate our Mtbf first. Now one thing we need to notice, our n, there are a total of 25 values here, and we know that our Mtbf our Mtbf, remember, is our T all over n, and T is gotten by summing all the T values and divided by the number of failures. So now, if we sum all our values here, we say 18 plus 40 plus 98 plus 118 plus 186 plus 230 plus ... The last one, 959, divided by 25, which is our n. We'll be able to get a total of now if we add all of this, we'll have a total of 14,276. You can cross check that. When we divide it by 25, we'll have 571.04 hours. All right, so this is the mean time. This is the mean time between failures. All right, this is the mean time between failures. If they are giving us just this highest time, for instance, if they are giving us just this highest time, and for instance we are giving the lowest time, now look at these guys. For instance, now we say 959. All right, let's say minus the lowest time there is 18, then to divide it by 25, you'll see that we are getting 37.64. all right, so it is a totally different answer when you are giving the highest value and the lowest value. All right, only, but if you're giving all the values, please add all of them and divide by the number of values. All right, add all of them and divide by the number of values. But even at that, if you're able to calculate that, you're not even going to divide by 25, because you're not giving 25 value, except it is stated that there are 25 equipment. All right, so if we say, for instance, 959, just for instance, so 959, then let's say minus the smallest value is 18, then this equals to, then divided by 2. We are still not going to get this value. We are still going to get it at 470.5. all right, so it's sacrosanct. It's important for us to note that if you're giving all the values, just add and divide by 25. You're giving just two values, the highest and the smallest, subtract the highest by the smallest and divide by 2 to get your average. That is to get your Mtbf. All right, so now that is for the first one, which is Mtbf. All right, so now the B part is to calculate the reliability, which is R. Now I told you that R is equals to E raised to the power, that is exponential minus lambda t. All right, exponential minus lambda t. No, we are not giving failure rate in this question. All right, we are just giving, of course, the time, maximum time. We know that t here is 1000 hours. All right, lambda is what we don't even know here. We don't even know our reliability as well, but we can get lambda. Remember that your Mtbf is equals to 1 all over lambda. That is in the question where they give you failure rate to. That thing that we solve, we will not do as summation of all those numbers divided by n if we are just giving lambda. If we are just giving lambda to get Mtbf, just do 1 all over lambda and you get your Mtbf. But here now we don't have a lambda. We need lambda to be able to solve. All right, so lambda now will be 1 all over Mtbf, and you know that Mtbf 1 all over 571.04. Now this will give you 1.751 times 10 raised to power minus 3 per hour. It means that there is a failure of this in every hour. This is more like the mean failure. In every hour, you have 1.71 times 10 raised to power minus 3 per hour. That is 1.71 times 10 raised to power minus 3 likelihood of failures in every hour. That's what failure rate means. So now that you have gotten it, so it means that your arrow will now be e raised to the power of minus lambda, that is minus bracket open 1.751 times 10 raised to power minus 3, then times 1000. All right, times 1000. So when you solve that, your arrow will be equal to, okay, let me show you how to go about that. So this is how you plug it into your calculator. Okay, please, E is not 10 raised to the power. E is not 10 raised to power. Look at 10 raised to power in your calculator. Shift. Okay, that 10 raised to power is like anti-log. All right, but see E here. E is shift lin. Are you seeing it? So raised to the power of minus. Okay, I would prefer you open a bracket. Okay, minus 1 minus bracket open, because it's minus lambda t. So minus bracket open 1.751 times 10 raised to the power of minus 3, then times 1000. All right, so this will give you 0.1736. So this will give you 0.1736, which is approximately 0.174. all right, approximately 0.174. So do you know what this means? What this means is that okay, we'll interpret that. Let me leave what it means first. We'll interpret that. That is the last question we are going to interpret. But in the next one, as C, the next one, we are told to determine unreliability. And unreliability is denoted as Q, and Q is 1 minus your reliability. Now, if for instance you are not given reliability, you have to solve for reliability before you get unreliability. And this will be 1 minus 0.174, and when you subtract that, it will give you, now let's say 1 minus 0.174. now this will give us 0.826. All right, 0.826. So this is the unreliability. All right, so now let us interpret. So C interprets results. All right, interpret result. I think that was, yes, that was C. Okay, this B, that was today, this one was just like II. This was just like II. This one is like AI. All right, not artificial intelligence. All right, so now let us interpret the result. So do you know what this means? Is that in 100 hours, at the 1000 hours rather, at the 1000 hour, okay, now it means that this you express this in percentage. All right, express it in percentage. Okay, so express this in percentage to know the percentage. So you do it, multiply by 100 to give you 17.4. all right, so when you multiply this is 17.4%. all right, now this will be I think 82.6%. Yes, if you multiply this by 100, you have 82.6%. Now it's important for you to note that in interpreting result, now you now say this. Now at the 1000 only 17, this time around you round it up to your nearest whole number, so 17%. Round this up to your nearest whole number, this will be 18%, 82 rather, 82%, I beg. All right, so 83%, please, 83, because this is a 2.6, so 83%. All right, so now you say at the 1000th hour, only 17% of the components are expected to still be working, while 83% will have failed. That's what it means. That is all those they are failures. That means that the 1000 are a whooping number of 83%. 83% will have failed. Now 17% will still be working. So when we talk about reliability, there is no time that you say until all the equipments are no longer working again. You, in fact, when you don't have any form of reliability again among components, is when you have 0%. It means when your Mtbf is 0%. All right, when your reliability rather is 0%. Okay, 0%. That is when at that point in time you say no equipment is reliable again. Okay, when your reliability is 0%. So even if your reliability is 1%, if your reliability is 1%, what it implies is that at that point in time your unreliability will be 99%. Okay, because now the sum of your reliability and the probability of your reliability and your unreliability, when you add all of them together, is supposed to give you 1. All right, so if you want to know the state of reliability, you must first of all know your mean time between failures. Then after that, you will ensure you calculate your reliability, calculate unreliability. Then that way you'll be able to interpret your results. All right, so this is very, very fundamental in science laboratory technology, and of course anything that has to do with medical technology and handling of medical equipment. All right, so if you've not subscribed to this channel, do well to subscribe. If you found this video beneficial, please click the like button. If you have any question whatsoever, do well to ask your questions in the comment box below, and I will definitely answer you. All right, so if you want to reach me, okay, you can check in the bio on the bio of my YouTube channel, and you can be able to reach me via WhatsApp and ask whatever question that you have that relates to this. All right, so have a nice day. Take care.